So let's get started on this very important topic, orchard design and tree planting. What if I ask you this simple question? What are you farming? You would say almonds, right? It's a simple question. And of course, when you farm almonds, you're farming almonds. If you're farming peaches or cotton, grapes, you're obviously farming that crop, just as simple as that. But my question is a little more complicated than that. What if I tell you that you are not actually farming almonds? You're farming light. Think about it for a moment. And I want you to change your perspective and think about the light, which actually is the basis of everything. Right? Light carries out photosynthesis. So start thinking about in terms of photosynthesis, which is triggered by light, and then the water and carbon dioxide is involved, and the plants make food, then the carbohydrates. The carbohydrates are really the energy currency of the plants that they use, the budget for use, and they use for their growth and producing obviously a crop that we all get. So light is very important, and the goal is to capture as much sunlight as possible throughout the life of your plant, through the leaves of the trees, so that they can produce to their maximum potential. Now, light is so much important that I landed in Georgia just about 30 hours ago. So yesterday was my first day. My body is still going through the jet lag. And I have a brain and my eyes telling me it's a day, but still my body will not believe it, right? It wants to shut down in the middle of the day. Even when my brain and my eyes are telling me. So think about the trees. The trees don't even have a brain, right? So they have different way of responding to their environment. So the way they respond to light is really going to shape the things in the way your orchard produces and you manage your orchard. So that is where I like to start when I talk about orchard design or tree shape, light. The more light your trees harvest, the more fruit you will harvest. So it's as simple as that. So the goal when we design a new orchard is to maximize the yield and tree life, tree longevity in the early years, and maximize that throughout the life of the orchard. So how to achieve this? Simply capture as much sunlight as you can as early in the life of the orchard, through the leaves, through the canopy of the plants as possible, and then your trees will produce higher and longer. Let me just take you back to some basics. What we call in physiology the photosynthetically active radiation, the PAR. Okay, so that is that part of sunlight spectrum, visible spectrum. So right around between 380 and 660, which is the wavelength that is very much active in triggering the photosynthesis and carrying out essential photosynthetic processes of the plant. Okay. So we talk in terms about PAR, the radiation that is photosynthetically active, that actually triggers photosynthesis. And we measure it in micromoles per meter square per second. Just as a reference point, the full intensity of full sun at noon without any clouds, it's about 1800 micromoles. So that is the full sunlight. Just to show you some difference in how much difference a shaded area versus fully daylight outside versus under the canopy, what difference does it make? This is the blue part of the spectrum between 400 and 500 nanometer wavelength. This is the green. This is the red between 600 and 700. So I don't want to go into too much details of the physiology, but I would say that there are two peaks, the chlorophyll A and chlorophyll B. One peak is in the blue and another peak is in the red. So the plants really utilize the blue light and the red light for photosynthetic activity. And look at this. This dotted line is basically inside the canopy, under the canopy. So this is basically the photon density in comparison with the broad daylight outside. So that is how much the light environment is different under the canopy, in the shade, and out in the sun. And that is what makes all the difference. The more shaded the canopy is, the more shaded the interior part is, the less photosynthetic capability the tree has. So, okay. So the next term that I would throw in the mix is canopy light interception. Basically, it is the term used for the amount of light that your tree's canopy is receiving and intercepting before that light falls on the ground. So canopy light interception would be the higher the canopy volume or the bigger the canopy is, the more light it is intercepting from the sun. Because when the sun rays directly coming from the sun, they fall on the empty orchard floor, they are not utilized for crop production, right? So they're wasted. So any light that will fall on canopy, on the leaves, and not fall on the ground, it will be utilized. So canopy light interception is basically a measure of how much light on an acre basis, or you can talk in hectares, per hectare basis, how much percentage of that orchard floor is shaded with the canopies, which means the trees are really capturing that light, and how much is empty. So that is really the relationship in terms of productivity of the tree, the yield of the tree, based on how much light it intercepts. Okay. So these are the graphs, one for almonds and another for walnuts. This is the orchard age in years. And just look at the almonds. And this is the midday par interception. So how much light the trees intercept at midday when the sun is up above on the top. So it really increases exponentially with tree age. In the young trees, less than 5 years, the canopy light interception is in the 20s. So basically the young trees are only occupying 20% of the space in terms of their canopy based on the total orchard floor. As the canopy increases, and you are aware of that, the orchard attains their maximum canopy size and then maintains it before the trees start declining and the orchard age gives into falling trees and the orchard needs to be replaced. In California, the university research shows that roughly the estimated almond orchard age is about 25 years. So it's a kind of bell-shaped curve throughout that period. The canopy light interception grows from lower 20s all the way to 80%, and then it stays there, plateaus there. And then as the trees get older, some trees fall over, some limbs break, and there's a lot more light again, so the canopy light interception starts declining. Our goal for the orchard design should be to maximize this potential to get to this point early on and then stay there for maximum production. Now, if you look at this, we stopped at 80%. We still have some place between 80 and 100%. So why not full 100% coverage? Because research shows that 80% is the maximum optimal canopy light interception that you can use productively, because if you go beyond 80%, that means you're creating too much shading in the orchard. And that shading brings in a lot of complications. One, it increases pests and diseases in the orchard. And also, number two, it creates so much shading in the lower parts of the canopy that the trees, greater parts of the tree canopies are shaded itself. So the spur, if you remember from my previous presentation, the spur life is directly proportional to the amount of light it receives throughout its life. So if the spurs are getting shaded for prolonged periods of time, they will stop producing and they will eventually die. So you have to leave some room for the light to get diffused through the canopies. So 80% canopy light interception is basically the goal. This is the chart developed by Dr. Bruce Lampinen. He is the almond and walnut specialist at UC Davis. This chart really is very important that, and I converted it to kilograms per hectare. Maybe it's 56 basically. Yeah, I remember I changed it to 56. So Dr. Bruce Lampinen's research shows what he did. He basically measured the canopy light interception on thousands and thousands of hectares across the state of California, and he threw all that data in this graph. So this is basically the canopy light interception data for these many years throughout the state of California. And you can see the correlation. This is the midday per interception, canopy light interception in percentage, and this is the yield in kernel pounds per acre, okay, which is really easy to convert into kilograms per hectare. So it increases linearly. So as you increase the canopy light interception up to 80%, the yield increases from all the way from 0 in the young trees to 3,000 or 3,500 pounds per acre. So 3,000 would be right around 3,400 kilograms per hectare. Look at this little clump here. So when you pass 80%, your yield drops significantly. That is because of too much shading, that's because of the diseases and pest pressure that too much shading brings. Okay? So the crux of that research is basically that 1%, every 1% increase in light interception brings in an additional 56 kilograms per hectare higher yield potential, up to the 80% canopy light interception. Another thing that is evident from this data set is that the best orchards in California are between 4,000 to 5,000 pounds per acre, which is right around 4,300 to 5,500 kilograms per hectare. But the state average lies around 2,800 to 3,000 of all the orchards. Okay. So let's go back to the orchard design objectives. The objectives that we have when we are planning and designing an orchard is, we want high yield of quality fruit. For that, we need the trees to quickly fill the available space. We want efficient light interception. Again, I cannot emphasize this point enough, that life of the spur is directly related to the amount of light it receives. And light exposure basically is related to the canopy shape and the position of the spurs within the canopy, and whether or not those spurs are way too in the interior of the canopy or they are in a well-lit environment. So it again goes back to training the tree into proper shape, which in California, through years of research, they have settled at an open vast shape, open center canopy that lets in a lot of light. So another objective for an efficient design is basically that orchard has to be managed easily. So efficient and easy management. You don't want any complicated planting patterns or trees too close for their vigor that they intercept the machinery and equipment and people. So you need to have that orchard setup, that tree design easily manageable. Also easy for movement of harvesting machinery and other equipment. And weed management is an important thing. So you have to have a proper weed management equipment and techniques for easy management. Less labor requirement. Now, in other fruit crops like peaches or cherries, they are too labor intensive. Even when you harvest those, you need manual labor. So those trees are specifically designed, or orchards are specifically designed to reduce the labor involvement. But nonetheless, the almond orchards are also designed to reduce labor. For example, there are expenses in pruning. There is labor involved in pruning and other day-to-day operations. So your orchard design has to be designed in such a way to reduce labor. And if you reduce the use of ladders in the US, the insurance costs drop a lot. So that's one other consideration. So the final point in my orchard design objectives is to have less initial cost relative to the return on investment. You have all kind of different farmers. You have small farmers, you have big farmers, corporate farmers. So everybody wants to actually have a decent return on their investment. So if you have higher initial investment, but your return on investment is in question, then your design is not clearly efficient or beneficial. So this particularly applies to high-density orchards, for example. And in case of high-density orchards, you have a really high cost of trees because there are really high number of trees for every acre or for every hectare. So you really have to manage your orchard in such a way that you get high early production to make up money on that investment. So there has to be a balance between initial cost and the return on investment. So tree density, this is a simple calculation based on how to calculate the number of trees per hectare. I'm sure you're familiar with this. I really had fun, last 2 weeks while I was in California, just going back and forth between feet and inches and hectares and acres. So I forgot these conversions. But these are really simple to convert. On an acre basis, we have different calculations, but basically there are 10,000 square meters in a hectare. So you have your spacing, and you multiply your spacing, your row spacing and tree spacing, and you come up with a number, and you divide that number with 10,000, so you will get the number of trees per hectare. Planting design, this is basically classic textbook slide. This explains the common planting designs. You have the square design, you have the hedgerow, and the quintet system is basically a design that has hexagonal design that has a tree planted in the center. Okay. So there are a couple of ways to look at it. You have a square, bigger square in here, 1, 2, 3, 4, and then you have another row planted by planting trees in the center of that square. Okay. So if you look at them, they are really similar to each other with little differences here and there. But these differences make a lot of difference in your situation if you're, for example, organic, or in case of almonds, if you're using a lot of bees. So there are some considerations that you have to give thought to in order to choose the best planting design. And then there is hexagonal design. So basically there are, 6, 3, 1, 2, 3, 4, 5, 6. So, and then there's, in the center of hexagon, there is 1, 3. So these are really the classic orchard designs. There are pros and cons of each one. This is a square, the simplest design that traditionally people have used in walnuts, and even in the case of almonds in the old days, the row-to-row spacing and the tree-to-tree spacing is the same. Old plantings in almonds would be like 7 meters and 7 meters. So it's really a square. It's very easy to lay out, very easy to plant. But these days, it is not used because there is a lot of empty space in between the trees, which we could use more efficiently. But this design is still preferred in organic, for example, because remember, in organic, you cannot do chemical weed control. So in organic, you can cross-disc. You can go this way and that way in disking your weeds, and that really helps you control the weeds without chemical intervention. So square design is still popular with organic orchards. The disadvantage, so basically now in this case the trees are crowded because every tree has 4 trees on each side. So the canopies, where the canopies hit each other, they are really crowding each other. But then where they do not have any canopy in the center of the square, there's a lot of space that is wasted. So it's really difficult in those zones. And then obviously we have less number of trees per acre because the tree-to-tree spacing is large. So a little bit of modification to make the square a rectangle by reducing the tree-to-tree distance. So for example, if the square is 6 meter by 6 meter, now you reduce the tree-to-tree spacing to 4 meter or 4.5 meters. So you get a rectangle. Further, you just shift the alternate rows a little bit to actually get an offset square or an offset rectangle. An offset rectangle is the most popular planting design in case of almonds in California for a couple of reasons. One is, in the morning I explained to you the direction of the sun, the movement of the sun, and the potential for shading with one tree shading to another tree. If you look at it and think about it, this is basically sideways. These are rows from the way we look at it. This is sideways, but in a north-south planting, these rows will be north-south. Okay, so I always think that north is out. Right? So this is north, this is south. So your rows are aligned north-south. So you reduce the chances of shading further because now, if the sun is going from east to south to west, and in the afternoon your sun is this tree, this shade is here because the next row there's an empty space where this tree is. There is really less shading likely in that offset square. That's one reason. Another reason is they have, by experience, they've seen their studies of bee movement. Because remember, in a traditional planting in California, we have self-incompatible varieties. So they are cross-pollinated, so they need bees. And every row is a different variety. This is variety A, variety B, variety A, variety B. So these trees are pollinating these trees and these trees. Okay. So the bee movement really goes from tree to tree like this, and there is a lot of bee activity going from one tree to another and pollinating these trees. So this offset rectangle has really worked well in common California orchards. Hedgerow. So this is where things are getting interesting these days. A lot of experimentation, particularly in Europe, with the hedgerow system. A hedgerow is basically where you actually plant the trees very close to each other, but the row-to-row spacing is a little farther, so you create a hedge-like scenario. Okay. So in hedgerow, like in all other crops like apples and others, you have to modify the tree's shape and tree's structure really to fit the hedgerow successfully. Let's just go to historical perspective. Historically, the orchard tree spacing was 7 by 7 meters or even 7.5 by 7.5 meters early on. Maybe 50, 60 years ago, we used to have only 70 to 90 trees per acre, which is roughly 200 to 220 trees per hectare, which is very low density. Just like peaches, plum, and nectarines, we have the open vase and open center system in almonds. They came into bearing and production really slowly. The large-sized trees, the trees individually were large, so they filled up space slowly, but each tree would produce a lot of fruit because they were large. But low density has its disadvantages, which we can discuss later. Then we shifted slowly to the increased tree densities, mainly by decreasing the tree-to-tree spacing within a row. And it also associated with the introduction of chemical herbicides. So when you increase the tree density, and when you planted the trees closer in tree-to-tree spacing, the time for the tree to fill that space is really quick, so the trees reach their full potential really quickly. So why keep the trees short? Again, going back to my my light example. The yield is a function of total canopy volume and total light interception, and not primarily related to tree height. So that is a known fact based on the research, extensive research done. Okay, so it's not that if you have a very vigorous individual tree, that is going to yield twice as high as twice as well as basically a smaller tree. But it's basically on the canopy volume, how much total canopy volume is achieved. Going back to the canopy light interception, if you can achieve the same amount of total canopy volume on a hectare basis with more number of smaller trees, or if you achieve that with the bigger trees with smaller number, it's all a function of total canopy volume and not the number of trees or the tree height in the case of its individuality. So that's an important thing to learn when we are actually planting some high density trees. So another important reason to keep the trees short is to increase the light interception in the inner canopy, because again for reducing pests and diseases and for increasing the life of the spurs, that's really important. Ripening uniformity. In case of almonds, the nuts up and down in the canopy or outside and the inner side of the canopy, sometimes there is a lot of difference in time in terms of their hull split and in terms of their maturity. So we don't want a scenario where you have to shake a tree twice, because that's an added expense. And if the trees, if the nuts on the same canopy are maturing at at long intervals. Half of the nuts are maturing sooner, the other half later. That can create a lot of added cost to growing. So the ripening uniformity, so you have to have good light interception in the canopy. The labor costs, particularly in the high density orchard systems, the smaller trees, the smaller canopies you can manage through mechanization. So the labor costs are reduced. So another advantage of higher density, and I'm talking about high density here, not super high density. So higher density, in here I'm calling even 7 or 6 feet by 4 feet, 6 meters by 4 meters, a high density, because we still reduce the tree spacing. Right? So if you come to higher density, you will have higher production early on in early years, and you can bring in some return on your investment. Also, there is an important aspect that we sometimes ignore. The universities or breeders produce newer varieties which are high yielding, so they are in patent for early years, and everybody in the industry is planting those varieties. So if you are paying royalty on the new varieties and you want to tap their higher yield potential, so planting them and at higher density, they can actually give you the benefit of improved varieties early on. So this is an example of an apple tree. Basically, this chart shows the shaded area in the middle of a large tree, and the dotted area is basically where the light is maximum, and the dark area here is like moderate light, and this white area is not receiving any light. As we started using dwarfing rootstocks in apple, the tree height was reduced. Look at the smaller trees. Now 100% of the canopy is exposed to light here. So that made a lot of difference. So I'm just going to discuss, and I know in the audience we have a lot of people doing this super high density, and a lot of people interested in super high density. In California, this February, we at the California State University, our team, we started a super high density trial over there, which we just planted, but it is on the lines of with Agronomist and one other company in California. So I came across the research that Agronomist already has done on the hedgerow system, the super high density, and it's worth mentioning. This system started in Spain a few years ago. The goal of this system is to intensify the orchard production in the initial years. So they are basically starting production as early as second year. Another goal is to achieve full mechanization of not only harvesting but other operations like pruning and others. So the labor question is out of the consideration. In most cases, in the plantings by super high density through Agronomist, they are using the Rootpack 20, which is a growth controlling rootstock. So I have Rootpack 20 in one of my rootstock trials on California State University campus. So it really makes a huge difference on tree size. So you can fit in more than 1,000 trees per acre, which is more than 2,500 trees per hectare. So this information I took from Agronomist's website, and they have this graph which shows really high production early on in the early years and achieving full potential by year 6. So over there they talk about total mechanization, harvesting after the tree, which is a really key question these days in California, because currently there's a lot of dust produced when you harvest the nuts from the ground in California. Early entry into production, higher yield and higher return on investment early on. And then because of harvesting up in the air directly from the tree, there is increased quality in terms of Aspergillus niger and other fungal infection causing aflatoxic contamination. So there was a paper published recently on a super high density versus open center using Soleta, which is the CITA Spain developed cultivar. These trees are on root pack 20 by 4 meter by 1 meter spacing, about 2,500 trees per hectare. And the open center was on GF 677, 6 meter by 6 meters square planting, 278 trees per hectare. So they discussed the data from 8 to 9 year old trees. So overall, in a head-to-head comparison, in year 8 and year 9, the traditional open center trees still had higher canopy light interception, higher canopy volume, and higher fruit set per tree. So these are all the parameters that they discuss. I'm not going to go into the details of each one, but the take-home message is, whereas this open center trees were higher, they had higher canopy light interception. The super high density trees had higher fruit set percentage. So the initial yields per tree and per hectare were higher in the open center training system. But yield per canopy volume was higher in super high density. So what I learned from this paper is that still in this head-to-head comparison, open center yielded higher because they were bigger trees, they had higher canopy light interception, and from our learning about the canopy light interception, they have a direct relationship with high yield. But SHD has future potential, mostly based on directly from the tree, harvesting directly from the tree, and potential for full mechanization. But what I believe is there is a lot of work to be done in terms of selecting proper rootstock and selecting proper type of scion varieties to put on, which are really suited for upright trees and high density hedgerow systems. So there are some advantages of going with SHD with intensive management, but I think with the currently available plant material, we have a little way to go. I will present one more, research trial results. Not really the detailed results because this is really a very young trial. We set up in 2017-2018 at Virtual Nursery near Fresno in California. So this research trial is basically on central leader trees. So here, along with Dr. Garrett from Australia, and I'm part of that team, we are looking at the suitability of different new varieties for training to a central leader system, as opposed to the open center where you had the trees at 1 meter and then select the primary and secondary branches and develop an open vast shade. In a central leader system, you do not prune or tip off the central leader branch, so you keep that growing. You never head it back, not even in nursery, and you maintain that central leader. And then the lateral branches coming off of the central leader, you let the tree develop its natural shape and try to plant that in a high density system where the trees go rather upright than spreading. So this trial is really about exploring new genetic material and seeing which varieties are more suitable for this central leader system. Let me just mention that after planting, we did some selection, and we had to go back to maintain the central leader, because some of the varieties, they will just fork at the top and they will create multiple branches, and then we had to come back and prune out or thin out those branches to just maintain one central leader. The varieties really responded differently to this central leader training. So we have these varieties. We have non-pearl as control because it's industry standard. And non-pearl really has diffused branching. It is spreading kind. We have winters. Winters is a dart type. It bears on long shoots rather than bearing on spurs. Monterey is another standard variety used as control. And basically a little bit of horizontal branching. There's a new variety which is self-fertile variety from Burchell Nursery's breeding program called Shasta. Shasta has a little bit diffused branching, but it's more upright than non-pearl. So Shasta is upright and vigorously growing variety. So another variety, Varieties, is also comes from Burchell's breeding program. It is a moderate tree size, and it's a spur type bearing. And then you have advanced selection from Burchell's breeding program, Lassen, which they have not released yet. They also have diffused branching. And then all these numbered varieties, they come from either Burchell or UC Davis's advanced selection from the breeding program. So these are still the numbered varieties, and they are under investigation, so they are not released yet. So initial data from, this is the 30 year of the trees. So basically, really the first good harvest. Okay. So in terms of kernel weights, in terms per hectare, Shasta is really on the top. This is really vigorous variety, self-fertile variety, and this variety really took to central leader training really well. So this is a good variety to train to a central leader, and also self-fertile variety. Then the UCD number varieties and non-pearl comes right in the middle, with Varieties way behind. So let's look at what. This is the chart showing ease of central leader. This is basically the development index on how easy it was to train a particular variety to the central leader system. Because remember, I mentioned in the morning, the growth habit and the tree architecture is in the genetics. So you cannot totally modify or control with pruning. So a tree that is genetically built to be spreading and not developing as a central leader because of the weak apical control, apical dominance control. So it's not going to be able to grow as a central leader. So one good example is these varieties, these varieties. This is really low index. So we tried hard to prune out the laterals to push the central leader, but it never grew as a central leader. It basically kept on diffusing on the sides, to the sides. But look at Shasta. Shasta is really high in ease of central leader index of the known commercially available varieties. This is not a numbered variety, UCD 8201. This is really high in central leader index, but we cannot speak of this at this moment because it's still under the breeding program. So let's sum it up to say the benefits of closer spacing. The closely spaced trees are smaller, and they're less likely to have scaffold breakage or other problems. So they're easier to prune, so they may need less pruning. They're easier to shake at harvest. The research shows, the University of California's Cooperative Extension Program has long-running rootstock and variety selection and tree spacing trial near Modesto. in Central Valley. And these are the results from years of research in that trial. And they have, over and over again, they have found fewer mummies and less shaker injury on the smaller trees in comparison with the larger trees. The smaller trees are the closely spaced trees. They have better spray coverage, so there is less insect and disease pressure. And those trees may not fall over as easily because they are smaller. Their limbs are not as widespread, and their growth is controlled. So the orchard life is longer. Again, I'm talking about the high density, not the super high density. So don't confuse this with the ultra or super high density as in the agromural system. But I'm talking about the higher density than the old square fashion, like 7 by 7 meters. I'm talking here about, in this trial under the University of California's tree planting density program trial, the spacings are 22 feet by 22 feet, which is 7.5 by 7.5, and then 7.5 by 6, and then 7.5 by 4.5, and then 7.5 by 4. So the closest tree to tree spacing is 4 meters. 4, 4.5, 6, and then 7 and 7.5. So that is the tree to tree spacing in this trial that they have these results from. And they have seen significant difference in limb breakage when you have trees planted 7 meters apart, or even 6.5 meters apart. So if you are having greater limb breakage, that means you are losing canopy light interception. So the yield is low. So another advantage of closer spacing is if one tree dies, it affects the yield less. So basically, there are a couple of advantages. Now, when they compared the cumulative yield over 10-15 years, there's really, in terms of cumulative yield, by the end of the total yield, by adding all the years, there's not much significant difference between the farther spaced trees and the closer spaced trees, because it again goes to the total canopy volume that covers the orchard floor. So the closer spaced trees give you greater yield early on, but eventually, as the canopies fill the space, the overall total yield that you get for the life of the orchard, it is still in the same ballpark. So that is the result from this trial. Now, talking about orientation, we already had a very good discussion this morning about orientation, but I have this slide, so I will walk through it. North-south versus east-west orientation, I already explained the light aspect of it. The shading depends on the tree vigor, orchard ventilation. We see in California conditions, we see better orchard ventilation in north-south. And why orchard ventilation is important? Diseases and pests like mites or the scales, they like the interior of the canopy where there is a little humid, so they thrive in there. So this is why in California we generally prefer north-south orientation. This is my last slide of this presentation, talking about the current conventional orchard system in California. Again, I'm just plotting the previous picture of non-pearl variety, just to show you how the conventional tree is trained. I converted this to meters, 6 meter by 5 meter spacing conventionally. The trees are trained to open center, 3 to 5 primary scaffold branches selected in year 1. Then the secondaries and tertiary branches are selected from then on. The goal is to achieve 80% canopy light interception at maturity. So if you look at this orchard, so you see some empty spaces and you see some shaded areas. So if you club that together, the goal is to have 80% shading. So, and Dr. Bruce Lepinen's research, if you want to explore more about that, it's really fascinating. And he even developed an app, a cell phone app, where you can actually take a picture of the orchard at noon time when the trees are shading the floor. You can take a picture, and that picture is fed into that app, and that app tells you how much canopy light interception your orchard has. And then that will develop a correlation running the algorithms, and that will give you the expected yield of that orchard. So it's really cool research that he's done. So in California, the nuts are typically shaken off from the trees to the ground, and then they let them stay there for about from a week to 2 weeks to dry, and then they're lifted from ground. There are so many problems with that system, with the dust and aflatoxin contamination and all of that. So a lot of research is being done to improve that system. And then in California, these days, precision irrigation and nutrient monitoring is the key focus these days for maintaining yield and vegetative growth. So that is my presentation on orchard design and things that we need to keep in mind. Again, I'm open to questions before we go into our next discussion on varieties and rootstocks. With that, I thank you for your attention.
Ja, mikrofon stało do góry.
Dois saldos, cheguei a tirar. Dois saldos. Es omul ze gadam to.
Silveri abi kartuli ne oraya İngilizce.
Es aure.
Kesinlikle.
Hello? In the end you said that after shaking, nuts were laying on the ground for a few weeks. Did I catch it right?
Do they what?
So to dry out, they were laying on the ground for a few weeks.
Right.
So during this time, they will be shaped from the tree, they are on the ground. You don't irrigate trees, it's over. How it works?
Right, okay. Let me turn this on. Yeah, that's a really good question. You know, irrigation during that period is really walking a thin line, because remember, you know, we talked about the flower bud differentiation being at the same time as the trees are getting harvested. So you don't want your trees to get stressed for water. So it's really critical on how they manage. Now, the system in California has been that they prepare the orchard floor well in advance. The floor is compacted, and I'm talking about the micro sprinkler or the micro irrigation system where they have drip or sprinkler system. Okay, and so they really keep the meadows clear. The sprinklers don't touch the crop in the middle. They throw the crop on the ground, and then they sweep with the sweepers in the middle, and they pile the crop in the middle of the orchard rows. And then they can irrigate. The drip irrigation is really simple and convenient for that system. But even with the micro sprinklers, they can control the pressure and then irrigate at a lower rate. But to be able to harvest on the ground, they also have to stop irrigation before harvesting. So the regular practice is, in a typical orchard, you would stop irrigating about 2 weeks before harvest, because there are two things. One is you want your orchard floor to be free of moisture. Number two, when you are shaking the tree, with that shaking motion with the shaker, if your root zone, if your soil is really wet, and your tree is, have higher sap activity inside the bark really comes off. So there is more chances of shaker damage from the bark, bark damage from the shaker. So if you have high moisture content at that. So you basically dry out 2 weeks before shaking, you cut your irrigation and then prime your trees to harden the bark a little bit so that it actually doesn't come off when you hold it with the shaker. And also the root zone dries a little so that when the tree shakes, the roots are disturbed to a minimum. So you cut back on water, and then as soon as you shake the nuts off the tree, you bring the nuts in the middle, you have to harvest, you have to apply the water immediately. If you don't apply the water immediately, that water stress right after harvest, it actually can do serious damage, because the buds that are differentiating at that time, they can get stressed for water, they can abort, and the next year yield will be low.
So if you compare the shaking system to a harvester, for example, super high density, so you still can irrigate when you are harvesting, right? On super high density.
Mm-hmm.
So you don't cause the stress and during the flower, right?
Yeah.
And how does it affect on the yield for the next year, for example? So, I mean, if you can irrigate and if you harvest just straight away from the tree instead of shaking the harvest from the ground.
That's a good point, and you have more flexibility when you are harvesting off the ground. And by the way, in flood irrigation system also, when they fill the soil profile and stop irrigation 2 weeks 2 weeks before harvest, they can wait 2 to 3 weeks before bringing in another flood irrigation, and before that they lift the crop. But with the high density, the super high density, where you just shake the crop off onto the tarps and the machines and take it out to the orchard, you have much greater flexibility. One of the important things that the California growers, they've developed, even if they had flood irrigation or micro sprinkler irrigation, they have installed, with a little bit of investment, they installed an additional drip line, just a single line drip, which they do not use the rest of the year, they just use during that period of harvest. So they keep irrigating the trees little by little, just around the trunks, so the trees don't get stressed. So they have their own ways to manage, but shaking the crop off of the trees and having greater flexibility in irrigating would be a great thing. Now, let me just point out one thing. Almonds are native to arid or semi-arid regions, right? So Iran, in Central Asia, they are happy with moderate stress. So it's nice to have capability to be able to irrigate when you want, but still there are periods in the production season in the almond, the seasonal growth, the phenology, that the trees would like a little less water than more. Okay, so the trees are happy when they're under irrigated for those periods of time. For example, during hull split, and we'll talk about that later. Hull split is the time when you suppress irrigation and you do not lose any yield. The trees, if they are stressed to a moderate degree, it's in fact beneficial for the trees. So keep in mind that you have to avoid stress, but you have to avoid too much watering, and you have to strike a balance between where to stress the trees just enough so that they actually improve in their efficiency and in the disease. All right.
One question, please.
Okay.
My question is about what do you think? What system is the best for Georgia? I mean, is it super high density? Is it traditional system? And if we are talking about not ideal water and soil situations, what do you think? Which system can do better results on, for example, on high EC and for when you have not enough water? Which system? I mean, traditional, high density, or super high density? And which system would be economically and financially the best?
Okay. Yeah, thanks. That's a good question. Oh, sorry. That's a good question, but I would say at this time, as I stand before you and talk about these systems, I'm not fully empowered with different aspects of these production systems, particularly in Georgia, that I can fully answer your question. But there are a couple of aspects to developing the intensive, high-density systems. One is the full mechanization. Another is, that's related to the labor costs as well, and to harvest the trees off of the, harvest the nuts off of the trees directly. Okay, so that addresses a few things like aflatoxin contamination, for example. Okay, so if you have a problem, particularly in nut quality, then and if you're exporting your almonds and getting rejected because of aflatoxin contaminations, maybe that's something that you will consider. For the direct comparison, we have very few evidences of the direct comparison between the open century system, and I would say that it's the super high density system is really exciting, and I have had a lot of discussions with the Agromura people in California, and everybody is excited about that. But that does not mean that the conventional system is just out of fashion or out of place. There will still be place for developing those trees, because you have access to a lot more varieties which are suitable to traditional system. There are a lot of California varieties which grow really vigorously. There are a lot of good rootstocks that are compatible with those varieties. They really make nice tree. And the good thing is that those varieties are out of patent, so you're not paying like a premium to buy that plant material. Okay, so I mean, and there are other things that are dependent, and in terms of water, in our new trial, we are focusing on water use efficiency between the conventional and the super high density. In my previous observations from my rootstock trial, the Rootpack 20 has a higher yield per canopy volume, but the intrinsic water use efficiency for that rootstock is, in my trial, it was relatively lower than non-pro and Nimogard combination. Okay, so I think there will be a lot of work needed for head-to-head comparison, but I would still say that with the rootstock and the sign material that we have available, both in California and elsewhere, there are a lot of great opportunities to try these combinations in a conventional system, unless you have really pressing objective of just harvesting off of the ground from the trees or mechanization on a smaller scale. The traditional systems, like California, they have worked really well.
So,
You have less water usage on a root pack compared to nemagar?
On a per tree basis, yes, less water uses.
How less? How less? Maybe in percentages, can you compare?
No, I don't have that data, but I have a chart that I can pull up. Maybe I can show you tomorrow. I recently submitted a research paper on the water use efficiency. We calculate the water use efficiency based on photosynthetic capabilities. So for the same amount of biomass production, root pack 20 was using a little bit higher water. So there was difference in there. But on a per tree basis, because the tree is smaller, so it's using less amount of water.
But per area, if you compare, for example, acre to acre, those rootstocks, I mean, if you compare the area, we're gonna have less or more
Within a hectare?
Yeah.
So that really changes the game. See now, because now you're planting, so if you're planting the trees on root pack 20, and you have 2,500 trees per hectare, whereas you have 500 trees with the conventional system. Now, every single tree on root pack 20 will obviously consume less water. But if you are planting 2,500 trees versus 500 trees or 400 trees, it really again goes back to the canopy light interception. How much canopy? Because the water is a function of the usage is a function of the canopy. Right? What is using the water? The leaves are photosynthesizing and transpiring, right? So evaporation, transpiration. So it really comes to the overall surface as a percentage of that hectare. And in theory, if you have a 1 hectare, and if you plant 1,000 trees on that hectare, or maybe 5,000 trees on that hectare, and they cover 100% canopy, and then you have another hectare that you have your imaginary 1 tree that develops their branches and leaves and single tree covers the whole hectare, the water usage would be same theoretically. So basically it is a function of the overall canopy cover. So theoretically, so it's the function of the canopy cover that's basically going to affect your water usage. So, but that's a really interesting question, and there are a lot of questions to be answered.
So tomorrow we will see more in detail. Yeah. So tomorrow we will see more in detail.
Yeah, we're going to talk about water management and how to calculate the water needs of the tree based on the evapotranspiration and the number of trees per hectare. That's the calculation that we're going to do.
Thank you.
Yes.
ცენტრალური ლიდერული გაზრდილის
Sorry. We've got to switch. Okay, please.
როდესაც ხებობს დაფორმირებული ცენტრალურ ლიდერულ ფორმაზე, რამდენ წელიწადში იწყებთ სხვა ფორმირებას, მექანიზებულ სხვა ფორმირებას და რამდენ წელიწადში ერთხელ რა პრინციპით სხვაობს?
Okay. Yeah, very good question. Okay. I think the next topic is first we'll address the vegetative growth. We'll talk about the vegetative growth, and then I think by the end of the day we'll start talking about training and pruning. To answer your question, in California, now we talk a lot about training the tree, which means pruning the tree early on to give the proper shape. So that is the training part we already addressed. Now your question is to pruning. Once the tree attains its desirable shape and it grows to its mature canopy. Now your question is about mechanical pruning and when you start pruning and what's the principle of pruning. In California, we are now these days basically going back on like decades of learning about pruning, and we used to prune the trees really hard. Because a lot of people, they're coming from peach or cherry or plum growing, and those, for example, peaches are pruned really hard. Because the peaches are really different in their bearing habit. So the peaches bear on current season's growth, so you have to prune really hard to renew the fruit wood. The almonds are different. They actually retain their growth, reproductive growth. They maintain their spurs for years and years to come. So it takes an almond tree a couple of years to develop a new spur and then to maintain that spur in its vegetative state before it can actually start producing. And then it produces for so many years. So if you prune an almond tree really hard every year, you are going to lose a lot of production. So in California, we as a university system, a lot of other university experts, we are just doing a hands-off strategy, which means that we let the trees grow. Once we train them to a good shape, the only pruning that we need is what we call is corrective pruning, which is coming back every year and seeing if there are dead branches, or if there is any disease or diseased branches, or if there is too much shading. So dead and disease is obviously not a question you should remove. The shading comes in the later years. So to answer your question simply, by year 10, 12, if they are spaced out pretty good, I don't see any shading from tree to tree. Then in the middle, if there is equipment being, the trees are in the way of equipment, then you, what they call like hedge prune. So people mechanically hedge the trees. Now there is another strategy in that they don't hedge every row every year, because that's going to be a lot of regrowth, which we will address in the training and pruning. So let's see, we have this scenario. So these trees are getting into each other. So what if you, every year, you walk through this with the mechanical hedger and you hedge from both sides? Your rows will look really nice. But each cut that you make, it's going to produce so many lateral branches, right? And then next year it's going to be a problem. Then you have to do that again and again and again, right? So a good strategy is to basically prune, hedge prune one side of the trees every other year. So this year I'm going like in this row and then skip the next row, then next row and skip one row and then next. So that way,
in next year.
Yeah, next year. So that way you are skipping one row. So basically every year one side of the tree gets pruned and another side of the tree gets not pruned. So that way you maintain the fruit wood, you reduce the crowding, because each cut you make, remember that it's going to create crowding and shading. So that's another strategy. So mechanical, to answer your question, mechanical hedging comes very later in the life of the tree, when the trees are really becoming huge and growing into the equipment or the middles or growing into each other. Otherwise, only dead or diseased branches or corrective pruning if there's any shading. That's what we are really going to the recommendations.
Thank you.
Hello. You discussed about light intensity, and my question is about what is the optimal light intensity, and if there is maximum light intensity for the canopy or for the leaf base. I mean, if there is 1,800 micromole photons, is that going to be too much for the leaf, or it's not too much and it's never too much, or there are some practices that they are even spraying some kind of whitewash, there's cowling, to reduce the stress by the sun and by the heat. And does it make sense at all?
Yes. So now the clay material that there is clay material and there are anti-stress compounds that people spray very often in protecting the plants of the canopy and more so protecting the fruits or the nuts from sunburn damage. Now, in an almond tree, I have not, seen that practice too much because just based on the light intensity. So light intensity will not be a single factor in making that decision of spraying. High temperature and low relative humidity that actually speeds up water loss from the canopy and brings the tree to stress. Those will be the compounding factors that would lead to our decision to spray that. If you leave it on the intensity, full sun 1800, it should be okay. Now on the other side, what is low? I haven't recently I haven't looked at the light response curve for almonds. But off the top of my head, I can tell you that anything below 1,000, like in the 700, 800 range, would be limiting. If you go 700 or 800 or lower, that would be limiting. So any light intensity that you have above 800, 900 or 1,000, that would be enough for photosynthetic purposes for the tree's light response curve.
Დეკითხვა მაქვს, ჩვენ როცა საუბრობთ ტრადიციულ და სუპერინტენსიურ ბაღებს შორის განსხვავებაზე, მოსავლის რაოდენობა რამდენად განსხვავდება და კალიბრაციაზე თვითონ ნაყოფის კალიბრი რამდენად სხვადასხვა გვაქვს თუნდაც ტრადიციული და სუპერინტენსიური ბაღის შემთხვევაში. და რამდენად პოპულარულია ესე ვთქვათ სუპერინტენსიური ბაღები თქვენთან კალიფორნიაში, იმიტომ რომ რამაც თქვენ საუბრობთ ამ სლაიდებს უყურებ, აქ უფრო ძველ ტრადიციულ ბაღებზეა ორიენტაცია გაკეთებული, ვიდრე თანამედროვე სუპერინტენსიურ ბაღებზე. აი ამათი განსხვავება და შედარება პლუსი და მინუსი თუ შეგიძლიათ რომ მოგაწოდოთ ინფორმაცია ამაზე.
Thank you for your question. So, yeah, in California, we are, like I mentioned, we recently set up a super high density versus open center comparison trial near Bakersfield this February. So I am personally involved in that, and I'm really excited to see the head-to-head comparison. As of now, the only evidence that I have is from Agromira's data, which looks promising, but there are some unknowns still. It's a hotly debated topic in California. One is that you're making a lot of pruning cuts mechanically, and how the trees respond to those pruning cuts, and what that does to the overall lifespan of the tree. Okay? So that's one question that we still have not answered in the super high density trial, because not even with Agromira's system in Spain, because we don't have that many years into research. The other thing is about nut quality. The paper that Agromira presented on their website, they mentioned the nut quality in terms of aflatoxin contamination and low pest and disease pressure, but I don't speculate the nut size differences as of now, if I have to just speculate, but it'll be a matter of research to actually see if that has an impact on the nut size or nut quality. The nut size in almonds is really a function of the carbohydrate and nutrient balance early on in the season, and that's what has the most impact on the nut size development in relation to canopy size. So that's the question that I'm really excited, looking forward to answer. At this time, I don't have any other evidence from literature on how these systems will affect the nut size and shape.
I remember I got school something in the south of the city that we did we swallowed the crane, we have to survive almost as for something with the south basically, we jammed with others, but I might interest in rollers, we are so that the diseases. Congratulations, Rao, she was the oldest leader who Jamisel was and this business.
Okay. So, the central leader system, I have a few different trials on campus. Okay, sorry. Yeah. So we have a few different trials on campus based on the central leader and the pruning responses. So the reason behind central leader is to see which trees are suitable for planting in high density. Because one of the thoughts behind altering the tree shape is that we have evidence from walnut. The University of California's trial near Merced, they recently did a research trial on walnuts in the central leader. So they found that if you develop the central leader and then let the tree develop its shape on the sides, the lateral branches, and left it essentially unpruned, except the dead or diseased branches, of course, but other than that, no intervention to cut the central leader or anything. The walnut trees maintain their structure, maintain their branch growth habits in their own natural way, that the tree's yield was at par with the intensively maintained trees. So there was no difference in cumulative yield. Those trees, they started bearing differently a little bit later, but over the course of 5, 6, 7 years, the total production that came out of both systems was essentially the same. Now, for almonds, there are two objectives. One is to let the central leader develop. If a variety is very suitable to developing as a central leader, you don't have to disturb it. So you can actually maintain the natural shape of the tree and reduce pruning costs. So you don't have to go in every year to prune it. So it's basically saving, a lot of saving in pruning expenses. Secondly, there is a school of thought with one of our collaborative scientists in Australia. We have a sister trial in South Australia where you have these central leader trees planted. So the idea is to develop the trees like a Christmas tree shape, like tall, slender trees, and they can be planted right next to each other. Still not not the dwarf trees like super high density, but closer than we have currently in California. So if you can plant those trees closer with the tall trees, you can maintain the proper light into the canopy for those tall but thin trees. We can maintain a lot of light in the canopy and get good crop. And by planting the trees closer together, you can have higher per acre yield. At the same time, you can actually then have the capability of mechanically harvesting them. So harvesting right from the tree is really an advantage right now if you can do that in California because of all the environmental regulations. So those are two objectives that the central leader trees. But your variety has to be responsive to be grown as central leader because that's a variety characteristic that we are seeing.
აი თუ სინათლეზე ვისაუბრებთ ჩამოსებურად ამიუდება
Oh, sorry.
აი თუ სინათლეზე ვისაუბრებთ ჩამოსებურად უფრო ამიუდება ამ ხეს და უფრო არ განვითარდება ზომიერად რამდენი ტოტსა დავუთავებთ უფრო არ ჩამოხდება თუ მაინც ლიდერული და ჩამოსებული ეგრეები სინათლეს.
Okay. So the central leader on my learning from the trials that we have is we have two different tree shapes. One is the central leader, where you have laterals growing. You still need to select the laterals. You will not select the laterals like you would do in the conventional system, where you select 3 to 5 primary branches in the first year. But you still need to select the scaffolds on a central leader, because there can be, now the central leader is not limiting at 1 meter. It's growing up. It's growing taller, right? So on the trees on our campus, in the second year, the trees were growing at like 3 meters tall. Okay, and from all the way from the ground, or the place where you actually have to shake the tree, you have to keep that clear. From the first branches at around 3 feet, all the way to the top, the tree is growing lateral branches. So there can be a possibility of too much crowding in those. So we had to actually go in there and select the branches that were crisscrossing. So in the initial years, year 1, 2, 3, you cut off the crisscrossing branches and the branches that are circling around. So you have to do that maintenance training in the first year. You still keep the central leader, but you have to thin some of the branches to farm up the rest of the branches. And we'll actually talk about this in training and pruning, because there are two different cuts, the heading cut and the thinning cut. So when you head a branch, the response of the tree is to produce more lateral branches. But when you thin a branch, you completely take that branch off of the tree. So now the response is that the tree channelizes its carbohydrates to the remaining branches. So in the central leader training system, what I have learned is you still have to firm up the branches. So you cannot have like a lot of or dozens of thin branches. You have to have thicker branches to maintain strong tree structure. So you will need to thin some branches for that.
ერთ შეკითხვა მაქვს დამამტვერიანებელ ჯიშებთან დაკავშირებით. ყველაზე ოპტიმალური პირობა და სქემა როგორ არის, ანუ რა გვეცე განლაგებული, რომ მოგვცეს საუკეთესო შედეგი. და ამასთან ერთად დამამტვერიანებელი სიტყვაზე ფუტკარი ზოგი იყენებს სპეციალურ სახეობებს, რომელიც ამტვერიანებს აღნიშნულ გაქვს და ზოგი უპირატესობას ანიჭებს ჩვეულებრივ მეთაფლიე ფუტკარში. თქვენი გამოცდილებიდან რომელი არის უფრო მაღალეფექტური და ასევე დამამტვერიანებელი ჯიშები ყველაზე საუკეთესო შედეგი, რამდენი პროცენტი იძლევა 1 ჰექტარზე ამ ჯიშების გაშენება?
So if I understood that question correctly, it's about the bees, right? The honeybees. And the propagation, you're talking about the pollination and the activity of bees.
Honeybees versus other bees.
Okay.
Honeybees and bumblebees.
So yeah, honeybees. I have in California the standard the practice is to have the Italian honeybee, which is Apis mellifera. So that is the standard practice, and the university recommendations go with that bees. I'm sure there are other types of bees that might have effective pollination, but I have not come across any comparative research in California conditions to compare other type of bees. So as a standard practice, we use the honeybees, the common Apis mellifera honeybees. So for pollination purposes, I have the slides to show what we use for traditional setup for a number of beehives, for a number of frames per beehive. So I can show you that information on my slides. So we have some certain specific recommendations for cross-pollinated varieties. Now I also have some slides where they show that the self-fertile varieties, they can set crop without the bees because they are self-fertile. But to have a good crop, they can also really benefit from the bees, although you don't need that many bees for self-fertile varieties. But there is a significant difference if you install a certain number of beehives even in self-fertile varieties. So if that answered your question, we can discuss more about that when we talk about pollination bees.
Hello. Back to the pruning. Maybe it will be better without headphones because I'm speaking.
Okay. Yeah, it's really confusing going back and forth. Okay.
Okay. In Georgia there are many almond varieties. It is from America, it's from Spain, and the methods of pruning are more or less the same, and the trees are growing, the canopy is not so various. But I want to ask you, what should we do when we are meeting the orchards which has been pruned? It was headed for example, on 2 meters, and it is full of the branches, and the sunlight is not it's not covered well, and how to improve there the situation, because as I guess you like to your method is non-pruning method, and also I agree with you. And when farmers want to improve the canopy of the orchard, what should he do? And the second question is about the stem. If the tree grows and the branches are already, we see that it goes slow. How upper we should the stem? What is the maximum height of the stem? Time of the time. So we have to cut the low branches and make the stem up. How maximum? 1.5 meters or?
Oh, so you are basically asking the height of the head.
Stem.
The main stem.
The first branch. How high maximum?
Oh, the first branch.
Yes.
Oh, okay.
Because we see, I see the problems is rising because branches are going down, and it's very difficult to use, for example, herbicides.
Right. Yeah. So, good question. The first question about if the trees have been headed on top, mostly like some people mechanically head them, and when I talk about leaving the tree and its own shape and form and minimally disturbing it, I'm talking about that we are actually keeping that in mind from day one, right? So we have that in mind, that we are actually shaping up the tree, and eventually we're going to have minimal intervention. So that is easy if you develop to that system from early on, when from day one, you have that in mind that, okay, this is the shape of the tree that I'm going to achieve. And it's easy, you can achieve that. It's a different story when you to say that when you mess things up and then you have to correct them. So a badly shaped tree or badly pruned tree, and then you cannot just go back and have a hands-off strategy, because we will see that the responses for a heading from a heading cut. So if you do a heading cut, you already are encouraging a lot of lateral growth. Now you have to come back again and thin those. So as a simple example or rule, if you have a branch and you are purposely cutting it in half, now you should keep in mind that that branch is going to express in terms of breaking of the lateral buds. So initially it's just one branch, okay? And it has its apical control. It has dominant apical growth. So it is suppressing the lateral growth. So as soon as you cut the top, then the tree is going to express sideways. So there are going to be multiple branches arising from the side lateral buds. Now you need to, if you want to go back to your original objective of thinning the canopy or having less shade, then you must come in and follow it up with some thinning cuts so that you control the crowding. Otherwise, we have seen that if you top from the top, like to head from the top, it creates so much crazy growth on top that the light is not getting filtered inside the canopy. So that can create a disaster. So that's the reason you don't want to make any unwanted cuts in the beginning. So to correct those mistakes, maybe you can from that onward, you can make more thinning cuts and less heading cuts. Does it make sense? Because you will thin out the whole branches and stop making further heading cuts because that will encourage like the bloom shape.
I hope we will show you the trees like that, and you will show exactly what to do.
Exactly, and I was thinking while I was answering that this is a discussion that we need to have out in the field, and
yes.
we'll see. Thanks. Okay.
I have one other question. Can you hear me?
Yeah.
It's about the nutrient requirements or calculation. So I understand from the production here we can calculate according to field of kernel and vegetative growth. Now, what are the ways to calculate first few years before we are when we are shaping the tree and nutrient requirements, how much it should be? In a production year, I understand it's much easier to calculate how much you would do and vegetation grows.
Yeah, I'm really enjoying this conversation and really great questions, because you probably got hold of my material and you are asking questions that I really brought in my material, which makes me really happy that is the kind of information that you're looking for, and I somehow included that in many of my slides. So that's really encouraging. I have slides for young tree fertilization. Now, for the young trees, the objective is to encourage vegetative growth, but to create a balance between not putting too much nitrogen in the beginning here so that it has like long shoots and rank vegetative growth, but at the same time not to stress the tree for nitrogen. So To answer your question in short, as a rule of thumb, based on the recent research done like 4 or 5 years ago, done at the University of California trial, we have basically, and now we can basically convert that to grams. We came up with the nitrogen rate, and it is basically comes down to the young trees for the first year, for example. It is 4 to 6 ounces of nitrogen per tree. That is roughly the number, and 1 ounce is 28.5 grams. Let's say 30. So 30 times 4, 120 to 180 grams of actual nitrogen, not the fertilizer, the actual nitrogen. And then the goal is to not give like more than 1 ounce per application per tree year. So that is basically the one. Means that you don't want to put the whole 120 grams or 150 grams at one time, but in multiple applications with the maximum of 1 ounce of 30 grams per application for every year. So that is basically it roughly based on the conventional tree density. In California, the conventional tree density is about 150 or 140 trees per acre. So 140 times 2.47 would be like around 430 something trees per hectare. And with that density, just for the vegetative growth, it comes to 20 to 30 pounds per acre, which is 12 kilograms per acre, which means like 12 times 2.5 is 35 kilograms per hectare. That's what it comes to for every year.
But in a high density, not on a super high density, we should increase the amounts because we have more trees per acre and per hectare.
So the data that I'm going to show you in the fertilizer tomorrow is basically on a per tree basis. So you can calculate how many number of trees. So basically they broke it down to how much nitrogen in grams each tree needs, because in the high density, or in the what we call it the conventional high density in California, like 6 meter by 4 meter, for example. The trees, young trees in year 1, year 2, year 3, when they are not mature, when their canopies are not touching each other, you can deal with them on the per tree basis, because every individual tree is growing in their own, right? So, and then you can actually multiply that into 300 trees or 400 trees, whatever you have over the hectare. So it's really easy. I mean, if it's 400 trees an acre and you convert it back, so if you have 400 kilograms per hectare and 400 trees, that means you're applying 1 kilogram per tree. If you have 200 grams of nitrogen applying to 400 trees, so that means you're applying half a kilogram. So if you have 400 kilograms per hectare nitrogen, but you have only 200 trees, then based on the research, it will show that you are applying, the young trees will need 1 kilogram, for example, per tree. Let's say this example. So then you cannot apply 400. You have to apply 1 kilogram per tree, because a young tree is a young tree. Even if it's planted like 7 meters from the next tree or planted 3 meters from the next tree, that tree's nitrogen requirement is going to be same if they're trained the same, right? So we'll talk about that. Maybe if it got confusing, we'll talk about that in detail.
And we still need phosphorus and potassium. What about those, even in a first few years, in a growing years?
Yeah, phosphorus is a really, it's really needed for root growth in the initial year. So phosphorus is important for establishing the root system. So initially in California, the good practice is to apply the 15-15 or 20-21. So whereas you have 15-15-15 or 21-21-21 and P and K. So they did some work on the 15-15, and they also have some data on phosphorus and potassium. So if you base it on the nitrogen percentage and application, you will have enough phosphorus and potassium for it. Potassium is more needed for fruit production and that growth, but phosphorus is really critical. Sorry. Phosphorus is really critical during the root stage. 15-15 is the common form. So, before we start on the next one, I don't want to. Let's. It's on vegetative growth now. Let me see. Okay, vegetative growth is 23 slides. So maybe, I can go through the vegetative growth, and then we can take a break and then come back for training and proof. I don't think I will be able to wrap it up in 15 minutes. So maybe now you can take a break. We have to take a break now. Yeah. And then we'll come back for vegetative growth and then.
Okay, მეგობრებო, ცოტა შევისვენოთ და გავაგრძელოთ.
I'm very good at this.
May I ask you some questions?